In this problem, we're given n numbers, and we have this operation in which we can choose an index I, and then we can change the sign of the numbers at index ai and ai plus 1. And our goal is to find the maximum possible value of the sum of the elements in this list after using this operation as many times as we want. So the obvious thing to notice is that the maximum possible value we can get is if all the numbers in the list were non-negative. So let's look at two cases. Now, for right now, we don't care about the size of the numbers, we just care about its sign. And 0 doesn't really matter because it doesn't add or subtract anything. So let's say we have a positive number, negative, negative, positive, negative, positive, negative. And in this case, we have an even number of numbers that are negative. So what I propose is that to convert all of these into positives, or as close to all of them as positives, what we can do is we can, if we see two negatives that are next to each other, if we choose this index, both of these will be flipped. So that's of course optimal. And now in this case, when they aren't next to each other, if we switch a positive and a negative, like here, we can do so such that now the two negatives are next to each other, and now we can convert these two negatives both into positives. So this logic of always trying to pair up these numbers that are negative and then changing them both at the same time only works if there are an even number of negative numbers. If there are an odd number of numbers that are negative, then that means there has to be one number that can't be paired up. So that means one number has to be negative. So let's say we have a list of, let's say, 3, 4, 1, 2, and let's arbitrarily make this a negative and negative. We can just switch the signs of these two and then switch to make it this negative, that positive and this negative, and then we choose this index and then we switch them both, and then now the sum, they're all positive, so the sum is maximal. However, if we have minus, 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 what we can do is we can switch these two, so there's positive and positive, and now there's one negative. But to maximize the sum, this negative should be on the smallest possible absolute value number in the list. So right now the sum is 8, 6, 7. If we switch the negative here, now it'll become 8, 7, 9. Right, so this is one larger, so this is the maximum possible sum. So how do you do this? So we're given, oh, that in tab, too much, int n, c in n, we have a list, and now we input the element in the list. And actually, while we input the numbers, we can do two things. We can calculate the number of negative numbers, which is starts off at 0, and we can calculate the overall sum, or the sum of absolute values, which I'll just call s for now. So then you do s plus equals the absolute value of ai, and then the number of negatives, and then if ai is less than 0, then we increase the number of negatives. As we know, there's one more negative. So if there are an even number of negatives, we don't do anything, because we know we can convert all the numbers into numbers that are positive, and therefore our answer is just s. However, if there are a negative number of odd numbers, then we have to do something. So what we have to do is we have to take away the smallest element of the list from this sum. So right now, in our example, what did I have? It was 4, 8, 1, 2, and there's 3 of them as negative, right? So what we want to do is our s would now hold, would be 4 plus 8 plus 1 plus 2. However, after we do all the changes, since it's odd, we want the smallest one to be negative, so we want the 1 to be negative. So in the end, what we want it to become would be 4 plus 8 minus 1 plus 2. Now to get this minus 1, we just simply subtract twice the minimum value, because once to take this away and then once to make it negative. So now what we do is we can also keep track of the minimum value here actually at the same time. So we just, I'll call it m as infinity, and then the minimum value is the minimum of m and the absolute value of ai. Right. So then our answer would just become s minus 2 times the minimum value, and then we just output s. Did I mess up brackets? Oh, yeah, I did. Okay, now I run g. Answer should be 19. Perfect. Answer should be 30. Oh, answer may not fit into a 32-bit integer. Okay. So just that should just make it long. Answer is big. Perfect. That works. And voila.